गुड मॉर्निंग दोस्तों, मेरा नाम सुरेंद्र कुमार है और आई एम असिस्टेंट प्रोफेसर इन AKGEC in CSC department. Today's lecture is based on discrete structure and theory of logic, that is BCS 303 code for BTech third semester student. So today I am going to give some introduction about the relations, binary relation that is used in your Poset and Lattices. So let's start. Basically, AKGEC syllabus has given the theory of set theory and relations. So in this first unit we have relations topic. This topic is useful in successive units also, because when you study functions, when you study graph theory, when you study logics, gates, so you need this relation topic as a introduction, and some basic concepts are required there. So I am here going to discuss these concepts. So all of you are aware about the set. Set basically is a collection of same data types, same datas that we have to study on. This set is represented in two forms. First form is roster and second is set builder form. Roster form basically is one kind of tabular form. Generally you represent like A. Here you have A is equal to curly braces 1 2 3 5 7 9. This is your roster form, and set builder form basically represent you a common criteria for that particular numbers, which is defined in the form of, like if we have a set B, that is 2 4 8 16 32. These elements are some relation. The relation has to be defined in a set that is B, that it can be represented as x, such that x is equal to 2 raised to power n. That means n belongs to a natural number, and value of n is greater than or equal to 1 and less than or equal to 5. So that's, in this way you can define your set as a set builder format. These are some standard notations which you must be aware about, as you have x belongs to A, x doesn't belongs to A, empty set, universal set, set of natural numbers, the set of all integers that is represented by I, and so on. So before starting the set, we must have knowledge about the ordered set. So what is ordered set? Basically, when you have a roll number of a class, so you have in a successive manner, in a order. For example, you have roll number 3, roll number 6, roll number 7, roll number 8, roll number 9. In the same way, if we have weekdays, so we can represent the weekdays in set format, that is a Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So these are the order of set. Now we can discuss the ordered pair, because when we discuss about relation, there should be ordered pair. So ordered pair means an ordered pair consists of two elements, such that one of them is designated as the first member and other as the second member. That means if you have A comma B, then there must be first member A and the second member B. So an ordered n tuple is an ordered pair where the first component is an ordered n minus 1 and second will be n, nth element. So you can represent it as n minus 1 comma n. Now we come to the binary relation. This is our main topic for today's. So binary relation, binary means you have relation between two elements. That's why we are using a binary. So a binary relation basically a relationship between the element of a set of the set is the next thing that come up. So relation may exist between object of the same set or between object of two or more sets. So we should have relation of this kind. We will take a small example, like let P and Q be the two non-empty sets. Non-empty because if it is empty, then we are not able to create a relation. That's why it is empty. Non-empty. So a binary relation R is defined to be a subset of P cross Q. That P cross Q is a Cartesian product of P and Q. So that forms a set P to Q. If you have set P and that is your, if A comma B pair belongs to R and R that is a subset of Cartesian product of P and Q, then A is related to B by R, and that can be represented in the form of A R B. So if set P and Q are equal, then we can say R is basically subset of P cross Q, P cross P, because P and Q are equal. So is a relation on P. For example, let we have set A and set B. So there may be some relation R on set A and set B in this form. This is your A related to R. This is your B related to R. This is your B related to T, and this is your C related to S. So this is a relation defined on some condition, right? So this, in this form you can create a relation. Let we see the second example where A and B are equal. For example, if A is 1, 2, 3 set and B is equal to A, then how you can develop a relation? So this can be relation to self, 1 to 1, 2 to 2, 3 to 3, or you can other also 1 to 2, 1 to 3, 2 to 2, 2 to 3. So you can have multiple relations here. So this is an example of basically relation which is on equal set. Now binary relation can have different number of sets also, or ordered pair also. So if a set has n elements, so how many relations are there from A to A? So generally this kind of questions arises many times. So how you can find out the relation number of relation in a binary relation set? So if a set A has an element and its Cartesian product will have basically n cross n, that is n square number of elements, right? Or if we have we can say if it's m cross n, that is m cross n number of elements. So in this way you can find out the number of elements in a Cartesian product. So there are basically 2 raised to power n square number of relation from set, from relation A to A. We can understand this with a small example. So if you create, before that we can take another example as I have taken. If A has m elements and B has n elements, so here how many relations are there from A to B or vice versa? So we can define, as in the previous example we have given, there are m cross n total number of elements in Cartesian product, and hence there are 2 raised to power m cross n relations from A to B. Here the example basically gives example of number of relations you can create. So we have a set A, right, and this set A have 2 elements only, 1 and 2. So determine all relations from A to A. So how you can find out the different relations or ordered pair 8 cross A? So as you have already seen, there are 2 raised to power 2 and equal to 4 elements in your A cross A, and that element will be A cross A 1 1, 1 2, 2 1 and 2 2, right? So now you can find out the total number of relations. How? What different kinds of relation can be prepared with the help of these A cross A, Cartesian product of A cross A. So, as we have 4 number of elements in Cartesian product, so now we can have a relation R1 just having a single element only, relation R2 which have again one single element but different, it is 1, 2 only. We have R3 element, relation R3 which is 2, 1 and relation R4 which is 2, 2. So, all the 4 elements of A cross A will represent a separate relation, right, R1, R2, R3, R4. Now, how we can go with the relation? Next relation, we can create also a relation having 2 elements. How we can create it? So, we can have first element of A cross A and second. In the same way, we can have first and third, that is 1, 1 and 2, 1. Here you can see 1, 1 and 2, 1. So, R6 is also a relation. R7 can be first element and third element. So, 1, 1 and 2, 2. In the same way, we can have R8, that is 1, 2 and 2, 1. 1, 2 and successive element 2, 1. Because we are using n minus 1 and n. Next element will be n minus 1 and n. Here R9 will have 1, 2 and 2, 2. So, you will have 1, 2 with paired 2, 2. Next R10 will be 2, 1. You can start with 2, 1 now. 2, 1 with 2, 2. So, if you are taking 2 elements in the relation, we can define the relation in this way, R5 to R10. Now, we come a relation having 3 elements. So, R11 will contain 3 elements if we are saying it R11. So, that is 1, 2 and 3 elements, first 3 elements. Then we can have first 2 and fourth element, that is 2, 2, that is 1, 1, 1, 2 and 2, 2. So, different combination can be created with the help of A cross A set. Same R9, sorry, this is R13. So, R13 basically is 1, 1, 2, 1 and 2, 2. Same R14 is 1, 2, 2, 1 and 2, 2. So, these are different possibilities of creating different relations using 3 ordered pair. Now, we come R15 which will contain all the pairs of Cartesian product. This is also a relation. And in the last, or you can say in the first, you can create a relation that is empty set. So, a relation can have also an empty set. For example, the relation condition is not satisfying, then it will be a empty set. So, now a very important point or very important topic of relation is basically to find out its domain and range of a relation. So, the domain means the first element. The first elements are called the domain of that relation. So, how you can define it? The domain of a relation R is the set of elements in P. If you are taking P and Q 2 sets, so the sets of elements of P which are related to some element in Q. So, that element has to be taken only which are in relation. So, or it is the set of all first entries of the ordered pair in R. So, it is denoted by DOM R, that is your DOM R. You can represent it DOM R also, right. So, that is domain of relation R. Now, we come to the range of a relation. So, range means as you have domain of P elements, then the range of relation R is the set of element in Q which are related to some element in P. So, it can be represented as ran R, and it is the set of all second entries in the ordered pair in R. For example, we have let A is a set 1, 2, 3, 4, it have 4 elements, and B is a set, it have A, B, C, D, these 4 elements, and some relation is given R on some conditions that is not defined here, but the relation is this. So, how you can find out the domain of that relation? So, as I have said you, I have told you that the first element of the ordered pair, the first element of the ordered pair is 1, here again 1, here again 1, there 2, 2 and 2. That means you have only 2 elements from first set, that is 1 and 2. So, these are the domain of this relation. Now, we say range of the relation. So, we can check out, here is A, here is B, here is C, here is B, same, C, same and D. That means all 4 elements of B are in this range. So, in this way you can find out range and domain of a relation. Now, what is complement of a relation? So, complement means you are aware about complement is just reverse, or you can say which is not present in a set, so that are complement of a relation. So, how you can find out the complement of relation here? So, consider a relation R from a set A to B. The complement of the relation are denoted by R dash. You can say it is R dash, right? So, R dash will be A comma B such that A B pair is not related to R. That means those ordered pair which are not in R will be your R complement. For we can take it with the example, with an example. The example is, consider the relation R from X to Y. If X is 1, 2, 3 and Y is 8, 9, 2 sets. Here 2 elements, here sorry, in X there are 3 elements, in Y there are 2 elements, and some relation is defined on X, Y, that is your R is equal to 1, 8, 2, 8, 1, 9 and 3, 9. So, now how to find out the complement of this relation? So, for this, first you have to find the Cartesian product of the sets, given set. So, Cartesian product of X, Y will be 1, 8, 2, 8, 3, 8, right? Then it will be 1, 9, 2, 9 and 3, 9, right? Now, we can find out the complement of relation R from X cross X. So, as you have total number of elements 3 in X and 2 in Y, so total number of element will be 6 in Cartesian product, and you have 4 pair in relation. That means in complement there will be only 2 pair. So, what other 2 pairs are? R is already containing 1, 8, it is 2, 8 also there, 1, 9 is also there and 3, 9 is also there. That means the remaining product, the remaining ordered pair 3, 8 and 2, 9 will be the complement of your relation, right? So, this is again an example of relation. Let A is 2, 4, 6 and B is 1, 4, 5, 6, then find out the relation from A to B, and that is defined on less than or equal to. The relation is less than or equal to. Also find out the range and domain of the relation. So first of all, you have to find out the Cartesian product of the relation. So you have 3 by 4 relation. A have 3 elements, B have 4 elements. That means total number of elements in Cartesian product will be 12. So you can define all the 12 product here and check the condition of less than or equal to. So you have to check the less than or equal to means 2, 1. 2 is less than or equal to? Not. That means 2, 1 will not be included in this relation R. 2, 4 is less than. That condition is followed. That means 2, 4 will be there. 2, 5 again the condition is following. So 2, 5 will be there. 2, 6 same will be there. 4, 1 that is your condition is not following with 4, 1 because 4 is not less than or equal to 1. So that's why 4, 1 will not be there. 4, 4 is basically is a relation here, that is less than is not, but it is equal to. So that means condition is following. That means this will be there also. 4, 5 will be there. 4, 6 will be there. 6, 1 again because 6 is not less than 1. So this will not be there. 6, 5 will not be there. 6, 5 will not be there, and the same 6, 6 will be there because it is equal to relation also following. Now we have the relation x comma y such that x belongs to A, y belongs to B, and the condition is x is less than or equal to y. So in this way you can have 2, 4, 2, 5, 2, 6, 4, 4, 4, 5, 4, 6 and 6. So this is a relation we can find out with the help of this condition is less than or equal to. Now we can find out the domain of this relation. As I have discussed before in the definition of domain, that the first element of the ordered pair are the domain of the relation. So the first element of the pair 2, 2, 2, that means 2 is domain, 4, 4, 4 that means 4 is domain, and 6 is your domain. So your domain is 2, 4 and 6, right? Now we come to the range. Range is the second element of your ordered pair, that is 4. You can write here 4. You can 5, 6, 4, 5, 6 and 6. That means 4, 5 and 6. That means your range is, and this is your domain, right? So all the elements of A are in domain, but range have only 4, 5, 6. 1 is not there as in set B. Now if we talk about the inverse of a relation, so there is a complement in relation in previous slide. So complement means those elements which are not in relation but in Cartesian product. Here inverse is basically defined as the relation R. R be a relation from set A to B. So then the inverse of the relation R denoted by R inverse, and that is the relation from B to E. That means your ordered pair will be reversed, or you can represent it as B relation R inverse A. If A R B, condition is if A R B. If A R B and A to B is present, then only you can define R inverse on that only. So for example, you have a set A 1, 2, 3 and the relation is given here is 1, 2, 1, 3, 1, 1, 2, 2, 2, 3 and 3, 3. So how we can find out the inverse of this relation? Just reverse the order of ordered pair. Here 1 2 will be 2 1, 1 3 will be 3 1, 1 1 will be same because the both elements are same. 2 2 will be same, 2 3 will be 3 2 and 3 3 will be same. So this is the inverse of a relation. Again there is one more example. We can have find the R inverse to the relation R on a set defined x plus y divisible by 2. So there is a set A which have element 1, 2, 3, 4 and 6. Now a relation is given x plus, for example, there is a relation x plus y divisible by 2. So how you can find out the relation ordered pair? So x plus y, we have to x plus y, 1 plus 1 will be 2 and 2 is divisible by 2, that means 1 1 pair will be there. If we take same 2 2 will be there, 2 to 4 but divided by 2, that is okay. 3 3 that will also be there, divided by 3 plus 3 is equal to 6, that is divided by 2 itself. 4 4 will be there, 4 plus 4 8 and 8 is divided by 2, condition is true. 6's will also be there, as 6 plus 6 is equal to 12, so it will also divisible by 2. What others will be? If we take 1 plus 2, that will be 3, that is 3 is not divisible by 2. So we will leave this 1 3 pair here, sorry 1 2 pair. If we come to 1 3, that is 1 plus 3 is 4 and 4 is divided by 2, that means we will take 1 3 pair. If we take 1 4, that is again 5 is not divisible by 2, we will leave it. 1 6 we will leave it, it is 7, that is again not divisible by 2. We take 2 3, will not take because 2 3 is 5, 2 4 is 6, that is divisible by 2, so we will take 2 6 and 2 4, and again 3 4 will not be divisible by 2, that is 7, but 3 6 again is not divisible by 2, that is 9. So the total relation ordered pair are this, and for finding out the inverse of this relation, you just reverse order all the ordered pair. 4 6, that is 6 4, 2 6 6 2, 2 4 4 2, 1 3 3 1, 6 is same, rest are same. So in this way you can find out inverse of a relation. Now intersection and union of relation will work as we generally use in normal intersection and union operation. For example, if you have R1 relation which contains, thank you very much, and you can find out more relations and other topics on this also, and you can send me your questions. If you have any questions, you can send me, I will solve it. Thank you.